So he's gonna be talking another hot topic and about the eternity naming system, and that's gonna be really interesting. I'm not gonna. Well, no, yeah. Before that, we're gonna break up for lunch after Michael's gonna give a talk. But during lunch, watch out. There's gonna be like somebody's gonna be announcing about a group photo. It's gonna happen here, but I'm not sure exactly what I'm. But just watch people shouting. So, anyways, Michal Zajda and Eternity Naming System, please.
Hi guys, and thank you. And great to be here again. This time, Eternity naming system. And today we are not short on time, so I will tell you 2 words about me. I'm protocol developer, um, and it's with Eternity over 2 years. And it's developing blockchain is very, very interesting especially when you come from distributed systems development. It's an adventure to know where to use some systems from the distributed systems and when you can cheat with crypto economy. And here I put some, let's say, formative experiences. I worked before with RTB, which shows how to scale vertically. IoT a little bit different, and massive online systems which show how to scale horizontally. So I took part in developing this chat app. Joined when it was 1 million, left when it was 250 million users. So it showed how to push some systems to the limits. And I got my science degree in machine learning in Poland. So we were supposed to talk about DNS for eternity. What's the mental model of the DNS? It's pretty simple. You have a name, aeternity.com, and you get numbers for it. So there is a reason why those arrows are not straight. Because very often when something seems simple, it's actually very complex underneath. It's exactly the case with DNS. There is browser cache, OS cache, the way they interact. There is hierarchy of DNS servers and the protocol they talk to each other. So in this presentation, let's see how it maps to blockchain and if we can even apply the same mental model to blockchain space. Or maybe it looks the same just on the surface. So yeah, what's DNS used for? The big one, UX. This is what we think. But actually there is a whole bunch of technical stuff. We can use those labels and hierarchy of labels to load balance traffic. We can use it for versioning. We can use some labels are legally protected. Or we can bootstrap our systems using labels, especially if the time life cycle of a certain system spans over time. And there is business. That's a gigantic area. Register name, obtain names. There are attractive names and boring names. And the whole area of marketing names, searching for them. Insurance.com was sold for over $30 million. So this is area that employs people and makes area for business. So does it apply to blockchains? Very much so. But surprisingly, the UX is the smallest part, the tech part. When we can influence versioning using labels, that would be interesting for contracts. That would make them more universal and secure. And business, just the same. If the blockchain takes off, there is a area to some things are attractive and simple to use. They can bring customers. Some are just not that impressive. So how does it work? Let's go low level. We know that we have addresses that are long hashes, and they are not easy to remember. So we can pick a name, and there are 3 steps 2 or 3 steps to start using them in transactions. So to spend instead of to a hash or to a name, to exchange spending to a hash with spending to a name, we have to call 2 transactions. Preclaim, this is where we signal the will to register a label, and at that step, the name is secret because we hash it, and later on we reveal that in claim transaction. Why is that? Why does it work like that? Well, it's part of this crypto economy, crypto ecosystem, which holds miners that we don't want to trust to. So first, so the only person can claim the name is the person who before that reserved that in pre-claim transaction. And new hard forks brings new features. From now on, when everything is clear, we can bid for the name. So if the name is so attractive that this insurance.com, say, the insurance.aeternity, would have market to and more interested parties, they can overbid each other for the day. And to make bidding simple and don't kill the blockchain with the bidding itself, we have to apply some crypto economic rules to constrain the traffic. For example, price progression is at least 5%. The graph in a slide shows you what's the initial price of the bid depending on the length of the label. So for the most attractive one-letter labels, it's about 570 tokens, which at today's price, it's roughly 100 euros, I believe. So all of that creates barriers, but yeah, this is what we have to do to make it actually more fair. And this is how it looks even lower level. These are examples of those 3 transactions I mentioned. First one is preclaim, and interesting part is this hash. It's the secret name, hash name. This is claim, so the name is revealed. Here it doesn't look so clear, but you can easily tell it by using a hash function. And here is another claim operation. Interesting part here is the sold is 0. So to obtain the secret hash, you need a real name and sold. But to take part in the auction, you just need to know the label that you like. So there is fundamental difference between real DNS system and blockchain DNS system. And the reason for that difference is cryptography. Regular DNS system, it's like a proxy. It's translation of user input into numbers, because underneath protocols use numbers. Networks use IP addresses, so that's simple exchange, one into another. Here, every transaction is signed. So these are real bits. We can't change anything. So if user signs the name, it has to stay like that till the very end. So our names live in protocol protected state tree. So this makes everything secure, and they are evaluated in the very context of those protocol state trees. And yeah, this is a very short presentation. I want to end it with a short story. I came here to Prague with a train, had a couple hours to, for myself, listen to a podcast. And the guest was Mark Andrezin. He's a VC veteran, not famous VC now, and internet veteran. He said that current crypto landscape reminds him early 90s, like 92, 93. And he he's actually in position to tell it because he was part of original Netscape team. So that's let's say credible source of information. And 93 was just before the big explosion, which is considered 94, 95, first big companies. And when I prepared this talk, I checked when the DNS was created. It was 1983. It gives me that feeling how many boxes we have to check to be ready for this explosion. Of course, 10 years, 20 years ago is not the same as 10 years now, but it's there is so many things to make our crypto ecosystem ready and ready to go. Thank you. Maybe questions?
One. Okay, let's just do it without a mic. So, yeah, you don't need a mic because it's not working.
I made a post in the forum about extending aliens.
Oh, wait. Thank you.
I made a post on the forum about extending AENS so that it could point to things outside of eternity, for instance, an IPFS hash or even an IP address itself. What do you think about it? How useful would this be?
Yeah, so first of all, it would be very useful. But there are some things to consider. So we should, first of all, we should not be so specific. We should bite the bullet and point to anything, to some sort of blob, to array of bytes. And let's say it's in a roadmap, but the problem is with bloating state. So we also, because it lives in protocol trees, so we need to apply a mechanism that will make sure it's expensive. So there are a couple corners to cover, and we should deliver that. Plus, there is this idea, I will try finally, extensions repository from Emil, that we can introduce this off-protocol state. If, say, spent transaction has a payload that can be any blob, if we start maintaining off-protocol state that is proved by spent to yourself, if we introduce protocol in this spent transaction body, all the vendors of the middleware will be able to use it, and it will be consistent across all the vendors if they ever exist. And it's not handling any assets, so it's not essential to have it protocol protected. So still thinking about it, but it may be some side alley to cover some use cases. So yeah, but you're right. Pointing to anything would be also useful.
One question from my side. I know that some of the wallets, or all, like at least two wallets, I know working also on integrating this auction mechanism in UX front end. Is there also a simple explanation on how to run this on the console or on the node directly?
Of course, we have a couple tests written, right? So you can just open the test and produce transaction. Even there is one, by the way, one condition, really long names don't trigger auction. So currently it's 31 length, size 31, but we should decrease that significantly. Lima is still some time ahead, so we will tune that for sure. And for the example, I would try one of the tests.
Would you say that a non-domain based name system is better at button phishing, for example, automatic checking of the public key of the website of the name?
What's the non-domain system?
Like aeternity naming system or Ethereum naming system or whatever, would they say they are better at button phishing?
This is word collision, but there are also different domains, let's say.
But for example, you could check within the browser the public key of the domain name and automatically come up with an answer and say, okay, this is the public key that belongs to the domain name because it's cryptographically based now. And then basically you get rid of phishing.
So there is no problem doing it now, right? It just depends on the vendors of the browsers. By the way, the secure DNS also depends on the vendors of the browsers and complicates the arrows even more because it changes how clients interact with OS and proxies. So I'm all for security and all about being exact. That's for sure. If we can solve it with the blockchain, sure.
Any more questions? Yeah, we have quite a few. So I think he was first, but I will come to you after that. Sorry.
Hey, so we know that some of the wallets are going to support the naming system, and we have an interface for that. The question is, once the bidding functionality is out, provided that it's what you said, it's 93 for blockchain, and you've spent quite a while, like you've put quite the intent into this bidding mechanism, but we really don't know how people are going to use it, and we also don't know if anyone's going to use it. So what are the next steps? Like, I mean, we're going to do some tests and staging, but once it's rolled out in production, what's the plan for, maybe measuring or adjusting, or like how does one in an environment like 93 figure out the next steps?
Let's observe it, that's for sure. And the fact is, we are in a phase of providing building blocks. So that's the essential building block. We can further extend it with subdomains or with blobs and so on. But that's a good moment to stop and observe. I don't have answer for you. We'll see how the market will take it. And I think I didn't said it. It was on my slide. Even obtaining the names takes time. You need like 31 days or 62 days for really, really attractive names to approve them for you and instantiate them in final naming record. Just to to make it just, let's say, and no one is missed because of unready tools, let's say. So we give time to the ecosystem to be ready to use all of this. So yeah, let's wait till it's popular and how to tune it.
So I've got a question about security. So is there a security mechanism in place which limits the size of the names? Because I imagine there will be spammers who will try to claim 5 megabyte long names.
No, it's limited. No, surely it's first of all, it's limited by the microblock size, but it's limited in the protocol. There is validation constraining the size of the name.
So what's the maximum size name size right now?
I'm almost sure that it's compliant with DNS one to make it transferable to be able to have on a blockchain the same what you have in a web. So it's 256. I don't want to pick it from. I don't know. Don't remember now. It's the same as in real web. That was the assumption.
Okay, thank you.
Any more? We have time? No? Okay, well then, thank you.
Thank you.